Hello, Year 7. Hope you've had a good break. We're just going to go through today a recap of some of the stuff that we covered at the end of last term. So we're looking at neutralisation, right? And we looked at that reaction in the lab, and we did rainbow fizz where we added an acid to a base, and we actually got salt and water and some gas produced as well, carbon dioxide. But I'm going to simplify it a little bit, and we're going to look at neutralisation as when an acid is added to an alkali. Okay, so what happens when that happens? We're going to look at the word equations and some uses as well. So first of all, I want you to use, here's the definition for this term neutralisation. I want you to write down in your books, okay? And then I want you to find all of these key terms and definitions from the sheets that I've provided you on your lesson, okay? It's important we have the meanings of those as well. So let's have a look at some of the uses of this term neutralisation when possibly something might be too acidic or something might be too alkali. What we can do is make it neutral on the pH scale, pH 7, by adding, if it's too acidic, we can add an alkali, or if it's too alkaline, we can add an acid to it. Farmers do this regularly. So a big problem in farming and producing crops is that our soils sometimes are too acidic, and we can measure the pH of soil using a pH indicator here, or you can take soil samples and actually measure it using indicator solutions like we have in the lab. However, this is better because sometimes the soil colours the solution. It makes it harder to read using universal indicator. So you can see here, look, this table here tells us the range of pHs that plants and organisms prefer to use. I mean, we can see which ones prefer acidic, slightly acidic, or slightly alkaline soils. So have a look here and see if you can tell. Yep, this one prefers slightly acidic, 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 slightly acidic. This one prefers slightly alkaline, and this one acidic. So if pH is below 5.6 or more acidic than 5.6, then what we need to do is make it more alkaline, bring it back towards the alkaline end of the pH scale to give it the best growing conditions. So farmers use stuff called lime to help them neutralise, and lime is an alkali. So when you add lime to the soil, you're adding an alkaline substance which reacts with the acid to produce salt and water. Now, if we look down here, we can look at this word equation where we have reactants on the left-hand side, products on the right. So I'll just move myself out of the way. So in this particular reaction, neutralisation, we have our reactants, acid and alkali, and our products, salt and water. Okay, so let's give an example of a reaction, a common reaction we might do in the lab, which we actually, I will get you to do, hydrochloric acid and sodium hydroxide, two chemicals, this one being the acid, this one being the alkali. Now when we can actually work out what the salt's going to be called in this case, because we've got clues in the names. Hydrochloric acid and sodium hydroxide actually gives us sodium chloride. Now this is a salt that actually you've probably eaten before. It's table salt. And salt is just a generic term for a compound that's formed from acid and alkali reaction, or acid and base reaction. And there's a few rules we need to remember here. So Let's just rip that out. If we want to work out the name of the salt, so naming salt. If the acid is hydrochloric acid, it forms salts with the name chlorides. Okay, let's think of another acid, sulfuric acid. Produces salts with the name sulfates. There's another acid, common acid we use in the lab called nitric acid. Have a guess, what do you think the salts are called if you use nitric acid? Well done if you got it. They're called nitrates. Now, if I swap any of those acids with this one here, hydrochloric acid, let's test you out, see if we can work this one out. So if I use sulfuric acid instead of hydrochloric acid, and I have sodium hydroxide as my alkali, what's the salt going to be formed? If you got this right, well done. The salt will be sodium and sulfate, so sodium sulfate. If I use nitric acid, the salt I would form would be sodium nitrate. All right, dead easy. So all you have to do is think about, okay, what's the type of acid I've got? What's the type of alkali? And I can form then the name of the salt from those two things if I know what those are, using those rules. Now, if the alkali is potassium hydroxide, for example, hydrochloric acid, potassium hydroxide, what would my salt be called then? Well done if you got it right. It's not sodium chloride anymore. It is potassium chloride. Okay, so I can mix and match the names to form the correct salt. Water is always there. It's always consistent. It doesn't change. Water is H2O. We get part of the H from the acid and we get the other O and the H from the hydroxide part there. But that always remains the same. Okay, so I'll give you a few